Everyone, welcome back to my YouTube channel. So today we'll be solving this chemistry past paper. I'll be solving the first 3 questions in this video and then the other 3 in another video. Okay, so this question is about elements X, Y, and Z, all right? An atom of element X is represented as 34 X 16, all right? Okay, so name the different types of particles found in the nucleus of this atom. Now, when we're speaking of atoms, they consist of the nucleus and the electrons surrounding it. So here are the electrons, right? And now the nucleus has protons and nucleons. So protons have a positive charge, and neutrons have a neutral charge, just no charge at all. It's not negative, it's not positive, it's just neutral. Okay, so that's the answer for A. So we'll just place protons and neutrons. Okay, so what is the term for the total number of particles in the nucleus of an atom? Now this is a term that you're supposed to memorize. There's really no understanding to it, but if you want to remember it, it's pretty easy. It's the nucleon number. So nucleon and nucleus, you can sort of relate them together. Another name for it is the mass number, but the marking scheme only mentions the nucleon number, so let's stick to that and try to get the 1 mark, right? So what is the total number of particles in the nucleus of an atom of this element? So total number of particles in the nucleus, that means we're going to take the protons and the protons and the neutrons, which is the mass number, and that is A, which is the top part. That would be 34. Now, what is the electronic structure of the ion? So this X element has a neutral charge, but now it has a -2 charge. Why is that? We can't remove protons, right? So right now, when it's at neutral, we have an equal number of protons and electrons. And since we can't remove protons, the only other option is to gain electrons. And how many does it gain? It gains 2, hence the -2 charge. So we have Z, which is the atomic number of protons. And like I said, number of protons is equal to the number of electrons in an atom, right? It's neutral. But since it has a -2 charge, it means it has 2 more electrons. So we were told it's 16 protons in this element. It gained 2 more electrons, so it's going to be 18 total. So we can place that as a note right here, 18 electrons. Okay, now when it comes to electronic structures, you always start with 2. 2 right here. So I'll explain it after, but let's just do this first. You start with 2, then the next shell of the electron will have 8. So that's 10 so far. We still have 8 more electrons, so we'll just add the other 8 electrons to the next shell in the atom. So let me explain that for you guys really quick. So here's the nucleus of the atom. We have the first shell, which can occupy a maximum of 2 electrons. The following shell can hold 8. So that's what we're going to do. We're going to hold 8 total. And we still have 8 left. So then the following shell will have the other 8. And now, here's something for you as well. There are 3 shells, hence this element is going to be in period 3. So the number of shells usually tells you which period the element is in. So for part 5, they ask us to suggest the formula of the compound formed between aluminum and X. So aluminum has an ion with a charge of -3, so 3-, and X we were told that it's 3+, and X is 2-. So since it's negative, it's gaining electrons. This is a nonmetal, and aluminum, it lost electrons, hence it is a metal. Okay, now what we're going to do is the crisscross method. So I'm going to get a different color. This 3 is going to go, whoa, that is very thick. Let me just make it a little bit thinner. This 3 is going to go down here. That 2 is going to go over there. So then your final answer, of course you don't have to draw all this stuff out, but your final answer would be this, AL2 X3, right? Now there is a formula that you can use that will help you figure out how many electrons can be occupied in a shell. And I believe that is 2n squared. So we're in the first shell. So n is the number of shells. So if we're in the first shell, it's going to be 2, 1, and squared. Let me erase some stuff because this is starting to get a little bit messy. So then that would equal to 1 squared, which is 1. 2 times 1 is 2, which is correct. Then we do this 2n squared again, 2n squared. We're in the second shell, so 2 squared. 2 squared is 4, so 2 times 2 is 4. Times another 2, so that's going to be 4 times 2, which is 8, right? So if we're trying to get the third one, then that will be 2 times 3. There you go, okay. 3 squared, which is 9, and then times 2, which is 18. So that means this third shell right here can hold up to 18 electrons, but we only have 8 left, so we just stop at 8. So yeah, that's how you solve the first part of question 1, and we're going to move on to part B. Okay, so what term is used to describe atoms of the same element with different numbers of particles in the nucleus? Like I said before, protons do not change. If you change the number of protons, then you're talking about a completely different element, because elements are described by the number of protons that they have. So the only other thing that can change in the nucleus would be the neutrons. And when these neutrons change, they're called isotopes. So they have the same number of protons, but different neutrons. Okay. Identify the atom against which the relative masses of all other atoms are compared. This is also a fact that you're supposed to know. So all these elements, they're compared to one atom, and that is carbon 12. Okay, so what is the name of the amount of any substance that contains 6.02 times 10 to the power of 23 particles? Okay, for example, we have 12 eggs. Instead of saying 12, we can say a dozen. It's the same thing with the 6.02 times 10 to the power of 23 particles. It's a mouthful. We don't want to say that all the time. So instead, we can say a mole. That's the word. A mole equates to that much. And now we move on. So the number itself has a name, and that name is based off of the scientist, and that scientist is Avogadro. So it's named after him. And yeah, that's part B. Pretty straightforward and simple so far. I hope it's all making sense. Now for part C, part of the definition of relative atomic mass is the average mass. That's important. The average mass of naturally occurring atoms of an element. Some relative atomic masses are not whole numbers. That is important to know. So element Y has only 2 different types of elements. Okay, some with 69 nucleon number and one with 71. And like we said, that would just mean that the neutrons are different. The number of neutrons, not protons, and these two are isotopes. Okay, so the ratio of atoms present in element Y is shown. It's a 3-to-2 ratio. So for every 3 atoms that have a mass number of 69, 2 of them have a mass number of 71. So they're asking us to calculate the relative atomic mass of element Y to 1 decimal place. So now we're going to use averages, the mean. Okay, so 3-to-2 ratio, that means the total is 5. So out of 5, 3 is given to 69 and 2 is given to 71. So let's write that down. So 3/5 of the atoms in general have a nucleon number of 69, so 3/5 times 69, plus 2/5 of them, yeah, have a nucleon number of 71. You place that in your calculator, and you'll get a number of 69.8. Okay, and then that's your answer. Now we want to identify element Y. What is element I? So we're going to go to the periodic table that you can find at the end of your past paper, and honestly you can remove it from the back and then restaple it afterwards, so then you don't have to constantly keep flipping. But yeah, let's see. Okay, so we're looking for 69.8. As you can see, it's all given in whole numbers, so we're going to round up, and that would be 70. So you can see that 70 is gallium. It's right here, right? So that is our answer. So you can place the name or symbol like so, Ga, or you can write out gallium. Either one will give you the answer. Okay, so part D. Element Z is in period 3, group 5. So, of course, you need to get yourself familiar with these Roman numbers. This V is a 5. So we want to identify element Z. Go back to the periodic table. So let's see. Period 3, group 5. So period 3 would mean row 3. So you have here the first row, second row, the third row. So it's somewhere here. Group 5, we got 1, 2, 3, 4, 5. This is group 5. Okay? So if you draw it out, okay, row 3, group 5, it stops here. It's phosphorus. So we'll go back and note that. Okay. Now explain in terms of electron transfer why Z behaves chemically as a non-metal. Okay, so phosphorus, because it's in group 5, okay, let me explain this a little bit better. Atoms in general, or ions to be specific, want to be stable. It's the most important thing for them, right? In order to be stable, they need an octet. They need to reach an octet. An octet is like a full shell. And in order to reach that full shell, they'll either gain or lose electrons. Now phosphorus is in group 5. That means, now see, the groups tell you how many electrons are in the outer shell, right? The valence electrons. Now we want to get to 8. How do we do that? Is it easier to lose 5 and go to the shell before? Or would it be easier to just gain 3 and get to 8? It's definitely easier to gain 3, hence why it's a non-metal. So, how do we explain it? Like I said, 2 main points. It's gaining 3 electrons when it forms an ion. Okay, so that is question 1, and now we'll move on to question 2. Okay, so magnesium is a metal. Name and describe the bonding in magnesium. So since it's a metal, you know right away that it's metallic bonding. And now we're asked to describe that type of bonding. So I'm going to draw it out real quick. So we have a metal sheet. We have magnesium ions, these circles, they're right here. These are the positive magnesium ions. And then you have the electrons just all around. And we consider that a sea of electrons. Okay, so let's describe it. There's an attraction, so you can say attraction or force of attraction between the positive magnesium ions and the sea of electrons. Okay, so that is part A of question 2. Now for part B, magnesium oxide is formed when magnesium burns in oxygen. Okay, complete the dot and cross diagram to show the electron arrangement of the ions in magnesium oxide. Okay, so it's already formed an ionic bond. Okay, so the inner shells have been drawn out. Give the charges on the ions. Now, magnesium is in group 2. Okay, it has 2 valence electrons. So that means it's a positive 2 charge, Mg2 plus. And again, magnesium, if you don't know, you can go up. We already know that it's a metal, and even if you didn't know about it, the periodic table, it tells you where metals are and where non-metals are. So this one in specific does not show you, but the line is drawn somewhere around here. I can't remember at the top of my head, but if you go online, you'll find the exact area, and then you can sort of just outline it yourself. But generally speaking, the first 3 groups are all metals. So we'll go back to the actual question right now. So since it's a metal, it has a positive charge, and then, like we said, it's MgO, and it's neutral charge. There's no charge here. It's a 0, and you don't really draw out the 0. So what can give us a 0? Even if we didn't know that oxygen is in group 6, so it means it only gains 2 electrons, so it's going to be O2 minus. You can infer on your own that it's going to be -2 because 2 plus -2 will give you 0. Okay, so we can place the positive charge here, so 2 plus and then 2 minus. Now, if you go into the periodic table, magnesium is in I believe period 3, but let's double check. Yes, it is. It's in period 3, and oxygen is in period 2. So period 2, period 3, we'll just note that here. So that means one's gonna have 3 shells, one's gonna have 2 shells. So we're gonna start with the actual atom itself, and then we'll change it. So they already drew the first shell for us. So we got 2. It's 3 shells, so we know automatically this one's gonna have 8. And then we move on to the next shell. That third shell is going to have 2. 1, 2. But those 2 will leave and go into the oxygen atom, but we'll do that after we finish with the oxygen. So the oxygen's in period 2 is going to have only 2 shells. Now, oxygen itself, let's find out how many protons it has. So if you go up to periodic table, oxygen has 8, if you note right here, and magnesium we know has 12 electrons. So if you go down, so we have 12 electrons here and then 8 electrons here. They already placed 2, so we're going to have 6 more left. So 1. See, we don't even have to look at the periodic table to get that answer. Why? Because in order to get the octet, in order to be stable, it needs 2 more. So then obviously 8 minus 2 is 6, and we know that it's 2 shells, so in the second shell, like we said when we use the formula, it can hold up to 8 electrons. So you can always try to infer these things on your own, even if you don't have access to the periodic table, but you do, and which is a great thing. So now all we have to do is to actually do it for the ions, so that would mean removing this shell because we got rid of both electrons, yeah? So that's going to be positive 2, and then we gained 2 here, but I made a mistake because I used dots when it should be x's, so be careful with that. So 1, 2, 3, 4, 5, and then 5, 6, sorry. And then the magnesium ones are circles. There you go, and you add it 2. So that's the answer. You can get rid of all the extra numbers, and that will give you the 3 points. Okay. So write the chemical equation for the reaction that occurs when magnesium burns in oxygen. So it's going to be magnesium and oxygen. Yeah. When it burns in oxygen, they already told us what the answer is. It's up here, magnesium oxide. So I'm going to put magnesium, we're going to put oxygen, we're going to put magnesium oxide. We have that. That's going to give you 1 mark. Now all we have to do is to actually balance it. So as you can see, we want equal numbers of the elements on each side of the equation, this side and this side. Okay, on the left-hand side, we have 2 oxygens and only 1 on the other side. So what we're going to do is place a 2 right here. Now we have 2 oxygens, but 2 magnesiums, and only 1 magnesium on this side, so we're going to add another magnesium. And there you go, it's balanced now, and you'll get the 2 marks. Okay, so let's move on to part C. So magnesium oxide also forms when magnesium nitrate is heated strongly, and it's an endothermic reaction. So when they're telling us it's an endothermic reaction, that means it's gaining energy, it's gaining heat. And when it's gaining heat, that is a decomposition or thermal decomposition reaction. That's part 2 of this question, but we can solve that right away. Thermal decomposition. Okay, so we have magnesium nitrate, and it gets broken down. So when it gets broken down, we know that one of the options is magnesium oxide. So right away, we'll go MgO. And they said it's heated strongly, so that means at the end we're going to have oxygen as well. It's going to be fully broken down. So magnesium oxide, nitrogen dioxide, and okay, so we have this. But now we want to balance, make sure it's completely balanced. Okay, so this 2 right here means that we have 2 of the NO3s. NO3, NO3, we have 2 of them. So that means 6 oxygens total and 2 nitrogens and 1 magnesium. Okay, 1 magnesium, it's correct. Here we have only 1 nitrogen, so we're going to add a 2 right here. So we have 2 of those. But now let's count the number of oxygens. 2 times 2, we have 4 here, plus these 2, plus a 1 here. That's going to give you 7, but that's not correct. So let's try this again. We can place a 2 right here. And what's that going to do? I'm going to change this up. Okay. We have 2 of those, so we're going to add a 2 right here. So then it's no longer an odd number, but an even number. 2 of those, but then that means we have not 2 nitrogens, but 4, because we multiplied this whole thing by 2. So we have 4 nitrogens, we're going to place that here. Okay, now let's count it out and see if it's balanced. So 4 nitrogens, that's correct. 2 magnesium, that's correct. Number of oxygens now. 4 times 2 is 8, plus 2, plus another 2. That will give us 12 total. And if you come here, we have 2 times 3, which is 6, and then 2 times 6, which is 12. So it's completely balanced out. And then that is your equation. Name 2 other compounds of magnesium that form magnesium oxide when heated. So this is something you should know in general. Those are carbonates and hydroxides. So magnesium. You'll notice what they all have in common is that they're polyatomic ions. So polyatomic means more than one atom, and well, ions, in this case polyatomic ions. So we have CO3 2 minus, and then hydroxide is OH minus, and then we have, and the last question of this paper. So sulfur dioxide is used in manufacture of sulfuric acid. In the first stage of this process, sulfur dioxide is obtained from sulfur-containing ores. Name one of them. So one of these ores is called zinc blende. So that's just something that you need to keep in mind. So when you go and revise these topics, you can always try and test yourself and just name these things and be like, do I remember this? You know, these are more facts than they are things that you need to understand. So just names in general. Okay, and terms. So the next stage of the process is the reaction, which can reach equilibrium. So that's the reaction shown below, and describe 2 features of an equilibrium. So equilibrium reactions in general have 2 things, and that is it's reversible. So you have the forward reaction, which is the 2SO2 plus oxygen give you 2SO3, and the reverse, where it's broken down and gives you the previous reactants. Another thing with equilibrium reactions is that they reach, with equilibrium reactions, the rate of the forward reaction equals the rate of the reverse. So they're happening at the same exact time, right? So those are the 2 things. Let's just write them down. So the reaction is reversible, and they're happening at their same rate. So rate of forward reaction equals the rate of the reverse reaction. So name the catalyst used in this stage. Again, this is something that you're supposed to keep in mind, and that is vanadium 5 oxide. Generally speaking, most catalysts are transition metals. Okay, so why is the catalyst used? something you should know, catalysts are used anyways to increase the rate of reaction. They're not actually used up in the reaction itself. They're not part of the reactants. They're only there to help speed it up. So they increase the rate in which the reaction is happening. So increase the rate of reaction. Now, explain in terms of particles why high temperature increase the rate of reaction. Okay, so here it is. When you have a high temperature, particles have more energy. They're moving around more, so the chance of them colliding with one another increases. So you can think of a little box and say you have these 4 particles. They don't have a lot of energy. They're not going to collide with each other as often. But if they were given a lot of energy, the chances of them colliding is greater, a lot greater. So if you have a greater chance of colliding, and the fact that they have an activation energy that's greater, like their actual energy is now greater than the activation energy, then you're going to get the products. So let's write that down. So particles have more energy. That is 1 mark. The rate of collision increases. You can say the rate of collision, you can say the frequency of collision increases. They're all the same. And then a higher proportion or a higher number of these particles now have energy greater than the activation energy. And if you're not aware, activation energy is the energy that's needed for a reaction to happen. So the particle needs to reach this number of energy before anything can truly happen. So they can actually collide, but then nothing really happens. Like they can just be bumping into each other and then they'll just move aside. Like no reaction there. So in this stage, only a moderate temperature of 450 degrees is used. So always pay attention to these key terms. Moderate, it's not a lot. They're not adding too much. So what does this suggest about the forward reaction? We can assume that it's exothermic. See, if it was a high amount of temperature, a really large amount of temperature, then we can assume that it's endothermic and it needs that reaction. It needs that energy. But here we're told that they're using a catalyst. So we can already speed it up anyways. It's being sped by the catalyst. And the fact that we're increasing temperature is just to reach that activation energy and again for the increased rate of reaction, of positive reaction going on. So we don't need a high amount of temperature if it's exothermic. So then that's how you that's sort of the thinking process that you should go through. So let me write it down. So catalyst, yes or no. And then another thing is temperature. Is it high, medium, low? So those 2 things will tell you whether or not you can assume that it's exothermic or endothermic. Now, calculate the percentage by mass of sulfur in sulfur trioxide. Okay, so let's go back to our periodic table and get those values. Okay, so sulfur has a mass of 32, nucleon number 32, and oxygen has that of 16. Grab your calculator. This is what we're going to do. We're going to have the total. So SO3 is going to be 32 plus 16 times 3, and that will give you 80, and that is the MR, relative molecular mass. Okay, we have that, and we're trying to find that of sulfur, the percentage, so not the fraction part, so we're going to multiply by 100. So that is going to be sulfur, which is 32, over the total mass, which is 80. And then we want the percentage of that, so times 100. That will give you 40%. Never forget the units, because sometimes they will literally take a whole mark off just for missing units. So be careful. Okay, concentrated sulfuric acid is a dehydrating agent, means it removes water. So dehydration, so it's something that's nice. It's like the terms aren't too difficult to understand here. Which can chemically remove water from substances. Both hydrated, so it has water, copper 2 sulfate crystals, and sucrose, which is a sugar, looks like this, can be completely dehydrated by concentrated sulfuric acid. Name the solid product formed in each case. Now, copper 2 sulfate, we're not given the water. It's not a hydrocarbon like sucrose is. So instead of hydrated, you're going to say anhydrous, so it doesn't have water anymore. And by that, it means the water surrounding it. Copper 2 sulfate. Okay, and sucrose, what's going to happen is you're just going to have carbon, and that's it. And why is that? Is because C12H22O11, we have H2O, so that means it's a 2-to-1 ratio. The number of hydrogens will always be double the number of oxygens. Here, oxygen is 11, hydrogen is 22, which is exactly double it. So we can remove all of that and it will give you H2O, but how many? Will give you 11 water molecules. Because 11 times 2 is 22, so 22 hydrogens and 11 oxygens. So what you're left with is just carbon, and that's it. Okay, so let's move on to part D, and the last part. So when propanol is heated with concentrated sulfuric acid as a catalyst, okay, an unsaturated hydrocarbon with relative molecular mass, 42, is formed in one other product. Okay, we can do this. So what is meant by the term unsaturated? Unsaturated means that not all the carbon-carbon bonds are single. And what does that mean? It means that some of these carbon bonds, so we have propanol. Let me just draw it out. So the term propan or prop means 3. So that means it's going to have 3 carbons. And 1 will tell you that the OH is going to be in the first carbon. I'm going to assume this is the first carbon. You can assume this one's the first. It's going to be the same thing. And of course, there's going to be hydrogens because carbon forms 4 bonds. So hydrogen, hydrogen. This is saturated because all the carbons bonds are single. If, for example, it was a double bond, like so, and then they're not all single anymore. Or it can even be a triple bond. So then we're going to remove another hydrogen. It's not all saturated anymore. It's unsaturated. So saturated is when all the bonds have been used up. So write the chemical equation for this reaction. Okay, so let's write the chemical equation for this reaction. We're told that concentrated sulfuric acid is the catalyst, so it's not part of the reaction. So we have C3H7OH, which is propanol. So you can count that. So that's why drawing it would be super helpful. You can count the number of hydrogens, carbons, and oxygen. We know that water is one of the options, so that's H2O. So we remove 2 hydrogens and an oxygen, so say these 2. There you go, that's your H2O. So what's left? We have C3H6. So 1, 2, 3, 4, 5, 6. And that's it. And to double check to make sure that this is correct, you can start counting. Carbon has a mass of 12, hydrogen has a mass of 1. So then 12 times 3 is 36 plus 6, which will give you 42. And then that's how you know your answer is correct. Name the unsaturated hydrocarbon formed. So let's draw it out. C3H6, 3 carbons, and 6 hydrogens. So 1, 2, 3, 4, 5, and 6. Now, this one's wrong. It shouldn't be there because that's a total of 4. 1, 2, 3, 4 bonds. So yeah, that's what it looks like. So now let's name it. That's going to be propene. Or if you want, you can say prop-1-ene, but it's not necessary because, again, that double bond can be either here or it can be placed on this side. Either one is fine. So yeah, that's it for the first 3 questions of this paper. Oh, it's only 5 questions. So there's 2 more questions after this. I'll see you guys in the following video. Share it with a friend to help them out, and I'll see you guys next time. And subscribe for more. Bye-bye.